All right, welcome to tonight's lesson. So in this lesson, we're going to be discussing sets. We're still on sets, except that today's lesson will be a bit detailed on the same sets. So the sets that we're looking at tonight is, simply interval sets. But before we go to interval sets, we are going to look at the laws of sets. Yeah, so after this lecture, I'm going to get some questions from the handout and also the assignments that based on sets. So when we are done with this lecture, we're going to get some questions from there. Meaning in the next session, we're going to have, it will just be question and answer. So I'll just be solving questions. Yeah, so I'll be solving questions and showing you how to solve them and how questions come. Okay, so let us quickly see what we can do. So like I said, tonight we're looking at the laws of sets and interval notation, and then we'll look at one example about interval notation. Okay, so before we can start, I would like us to look at the symmetric difference of two sets. So when we talk about the symmetric difference of two sets, it's denoted by this symbol, a triangle symbol. So if we say find the symmetric difference of set A and B, okay, normally we know to say when they just ask you to find the difference between set A and B, we say A minus B. And A minus B is just equal to A intersection B complement. We learned this in the previous session. And then the symmetric difference of two sets simply denoted by a triangle. And then you say A, you put a triangle there, then you say this is equal to, so this one is just equal to A minus B union B minus A. Then you put everything in brackets. Or if you don't want to write this, you can also find the symmetric difference of set A and B by using A union B and in brackets, then minus A intersection B. So these are the two formulas for the symmetric difference of two sets. You discover that if you use this one, you get the same answer as the person who used this method here. So I'm going to give examples tomorrow. Oh, sorry, the day we're going to have our next session. Okay, let's look at De Morgan's law. So on De Morgan's laws, okay, these are just laws that deal with how that tells us how we use the complement. So imagine you have A intersection B, then in brackets, and you have a complement outside. So when you distribute the complement, this A and that, when this complement is distributed to A, we're going to have A complement there, and then here in between you have intersection. It's going to change it to be union. Then you write your B, the complement will also be there. So I've just distributed this complement to both A and B. Okay, sorry for that inconvenience. Yeah. All right, so we have, this is how we distribute the complement. If you have something like this, you can write it like that. So what is just important is changing the sign in between when you distribute the complement. So the same applies when you have A complement intersection. Let me use union in this case. You have A complement union B complement. So if you want to factor out the complement, you want to put the complement outside the brackets, simply say A, and then the sign there will change. So this will be intersection, then you have your B there. Then you put your complement outside. So what is just important is that if you're distributing, you make sure that you change the sign in between there. If it was intersection, it becomes union. Same applies when you're factoring it out, you're factoring the complement out. Make sure that you change the sign as well there. So that is the basic concept that is on De Morgan's. Okay. So yeah, so basically the De Morgan's laws are simply just what we have there. The first one, the first two, this one and this one is actually showing us how we can use associative law, which we're going to discuss, I think, after this. Yeah, so this one and this one are talking about associative and distributive laws. Yeah, but De Morgan's is basically just this one here and that one. Okay, let us look at these other set laws. So the other things that you need to know are that the complement of the universal set is simply what? An empty set. So if you say the universal set complement, the answer is an empty set. What that means is that you have a Venn diagram like that, which has two sets, A and B, and then this is the universal. So the universal set is simply just the whole set. So if they say find what is outside the set, this side, universal set complement, simply just an empty set. So same applies if they say an empty set complement. An empty set complement, the answer is the universal set. This is the second one here. What if you have A intersection A complement? You have set A, which contains A and B. You also have another set A, which contains the same elements A and B. And then they ask you to find A intersection A. So A intersection A is simply just finding the common elements between A and A. So the common elements are what? Are A, comma B, and A, comma B is just equivalent to what? To the same A. So this is just the same as A. This is why we're saying A intersection A is A. A intersection A complement is an empty set. How do you understand that? So we have a Venn diagram there which contains a set A. So we have a set A there which contains two elements, 1 and 2. Then you have a 3 outside there. So we're trying to find the intersection set between A and A complement. So A is simply just what is inside the set there. And then A complement is actually what is outside the set there. So now we're trying to find the common elements between what is in the set and what is outside the set. You discover that there will be no connection there because inside the set you only have 1 and 2, and then outside you have 3. So that simply means we don't have any intersection. We don't have anything common between what is in set A and what is outside set A. Hence, A intersection A complement gives what? An empty set. What is A union A? So A union A is simply just A. So when you combine A and A, the answer that you get is still going to be A. When you combine A and A, the answer that you get is still going to be A. So, because, okay, let me give you this example. You have A is equal to A comma B. Then you also have another A, which is A comma B. So when you are finding A union A, simply means that you are listing, you are combining this set and that set. But remember one rule of sets: when you are combining two sets, make sure that you don't write the common elements 2 times. So in other words, you can't write that you can't write something like A, comma, B, again you write A, again, comma, B. No, you don't write things like this, no. According to rules of sets, anything that is present or that is appearing 2 times in a set, like the way we're seeing A and B there, you write them once. Hence, A union A is simply just going to be what? A, comma, B. These are the only elements that we have. So this is wrong. So this is the correct way of finding A union A. So A union A is giving us A, comma, B, which is just the same as what? A there. What is A intersection universal set? So A intersection universal set is simply just A, because the universal set contains what? Contains all elements. So if this is the universal set, for instance, then you have A, which is having 2 and 3. Then they ask you to say, find A intersection universal set. So A intersection universal set, the intersection means that we find the common elements between A and the universal set. So the common elements between A and the universal set there are simply just 2 and 3, because these are the only elements that we have in A and the universal set. So we have 2 and 3. And what this means is that A intersection universal set gives you what? The same set as set A there, which is simply just A. Hence, A intersection universal set is simply just equal to what? A. Okay. So A union universal set. A union universal set gives us what? Universal set. How is that possible? You have a universal set being equal to 1, 2, 3, 4. Then the set A there is 2, 3, 4. So, and then they ask you to find the union set between the universal set and A. What that means is that we're going to add this set and that set. We're going to put them together. But as we're putting them together, we have to make sure that whatever is common in both sets is written once. So we have to make sure that we write everything that is common once. So what that means is that we write the set. So we have 1 there, we have 2, we have 2. Since 2 is appearing 2 times, we write it once. We have 3, we have 3. Write it once. We have 4, we have 4 there. Write it once. So when you compare the two set, this set that we have found here, isn't it the same as the universal set there? It is the same. Hence, A, sorry, it's supposed to be union here. A union universal set gives what? The universal set itself. Out of A complement intersection A complement. So this one will still give you what? A complement. It's just the same as what I explained here, where I said A intersection A gives what? A. Out of A union A complement. So A union A complement is simply just adding the set A. So we simply just adding the set A. So let's say we have set A, which is set A, which is 1, 2, 3. And then let's say, for instance, the universal set is equal to 1, 2, 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5 as our universal set. So if this is A complement will simply just be what is not in A, but it is present in the universal set. So what are those numbers? We have 4 and 5, because 1, 2, 3 are also in A, but A complement means we find what is not in A, but it is in the universal set. So that is just 4 and 5. So now we're trying to find the union set between the union set of A and A complement. So when we find A and A complement, we combine these two sets. We combine this set and this set. What are we going to have? So this set there we have 1, 2, 3. Then in this other set we have 4 and 5. So combining these two sets is giving us this set there. So now if you check this set, isn't it just the same as that set? If the answer is yes, then this tells us to say A union A complement gives us what? The universal set. So sorry, I wrote A there instead of the universal set. Okay. Okay, let's move on. Let's look at the other set laws. We also have these.
Hello.
Yes, sir.
Sorry, sir. May I beg for a permission to take you back on number 4? Number 4, I didn't get it right.
Which one? This one?
No, yeah, the last page. Yes, that one, yeah.
This the same. Okay. So this one here, I was talking about A intersection A complement. So A intersection A complement, I drew something here to say if you have A, okay, maybe let me explain it in terms of discrete sets. So we have A, if let's say we have A being equal to A, B, C, and then let's say the universal set is A. The universal set is, oh, let me use small letters. So the universal set is A, B, C, D, E. And then this is what we have as the universal set. So now we're trying to find, this is our A, then we're trying to find A intersection A complement. So we already have A there, which is this same set there. So let us find A complement. So A complement is simply just, we write what is not in set A, but it is present in the universal set. So what letters are those? We have D and E. So we write D and E. So D and E are the members of A complement. So if this is what we have, the question is asking us to find A intersection A complement. So A intersection A complement, it simply means that we have to find the common elements between set A and set A complement. So do we have anything that is common between these two sets? Definitely no, we don't have anything common between this and that set. So the answer is what? An empty set. Okay. So we look at these other set laws. So these other set laws are also very important. Okay. Let me just change the color of the marker. Okay. These are also very important in the sense that these, they help us to prove, there are those questions that they'll ask you to say, prove that this set is equal to that. How do you prove that? It's very simple. So let me just show you. All right, so this is what we have. So we have A intersection B is equal to B intersection A. So this is called the commutative law. So the commutative law tells us to say it doesn't matter how you arrange the sets, the answer that you are going to get will still be the same. So that implies that you can have maybe A union B. So A union B is just the same as B union A. You still get the same answer. If you find the value for A union B and B union A, the answer will still be the same. So That is what we're trying to talk about. When you talk about commutative, it's just a matter of changing. So commutative in terms of the other operations, we can say 2 plus 3, the answer will be what? To be 5. Even if we start with 3, we say 3 plus 2, the answer will still be what? To still be 5. So when you change the numbers, you interchange the numbers and you still get the same answer. It means that the operation in between there obeys the what? The commutative law. If you say 2 times 3, the answer is 6. 3 times 2, the answer is still 6. So multiplication obeys the commutative law. 2 minus 3, the answer is -1. 3 minus 2, the answer is +1. Subtraction does not obey the commutative law because the answers that we're getting this side are what? Are different. 4 divided by 2, the answer is what? 2. Then 2 divided by 4, the answer is what? 1/2. This implies that division does not obey the commutative law because the answers that we've got in this side are different. So same applies to sets. So if you find A intersection B and you discover that it's equal to B intersection A, it means that intersection, or rather sets, let me just make it in general. When you're dealing with sets, the intersection symbol and the union symbol, they obey the commutative law, because when you interchange the letters, or rather the sets, the answers that you get will still be the same. When you talk about the the associative law, so the associative law states that if you change the brackets, if you have B intersection C, okay, let me be writing somewhere. So if you have A intersection B intersection C, and then you put the brackets this side, this is just the same as having A intersection B intersection C in brackets this side. So what this means is that when you are solving any mathematical problem, you always follow what is known as BODMAS. So this BODMAS states that you start with what is in the brackets. So if you start with these two sets to find the solution of this left-hand side, the answer that you're going to get will still be the same as the person who started with B intersection C and later added A and found the answer. So the answer that you get this side will always be the same as the answer that you get this side. If you start with A intersection B and end with C, is the answer that you get will still be the same as the person who starts with B intersection C and ends with A. So that is what the associative law states. When you change the brackets, you still get the same answer. So you can see how they change the brackets there. Then the distributive law states that if you have anything that is in the format A, if you have anything that is in the format A intersection in brackets B, let's say maybe you have union C. This can be distributed by getting A intersection, you add it with C. So you put A intersection, or rather you add it with B. A intersection, you add it with B there. You put it together with B. Then you get the symbol that is in between there, which is union. You put it in between. Then you write another A intersection. Now this time around you put it together with C. So you say A intersection C. So this is how you distribute. Same applies if you have A union B intersection C. The answer will still be, so you get A union, you put it together with B. So we say A union B. Then in brackets, you get the symbol which is in between there. You write it there. Then you open brackets, you put A union C in brackets. You put A union C in brackets. So this is how you distribute sets. So we're going to look at some examples tomorrow. I don't know what I'm saying tomorrow. The next lesson we're going to look at some examples, and you see how we apply these laws. So I've already explained the the De Morgan's laws. Yeah, so I've explained this where I was saying if you have A intersection B in brackets and then complement outside, if you distribute the complement, you're going to have A complement union B complement. So this is what you're going to have as the solution. Okay. Yeah, so that is the De Morgan's. Okay, let's move on. Let's discuss the other segment of today's lesson, which is the interval notation. So we are going to discuss the interval notation, and yeah, so every time
Before you move on, sir,
okay,
excuse me.
yes, sir.
My network was interrupting, so I didn't get it clearly on the associative and distributive law. Could you just kindly run through for my sake?
All right, so the associative, I was saying, associative deals with the interchanging of brackets. So if, for instance, you have the brackets on B union C, you can still put them on A intersection B, meaning the answer that you get this side. Okay, let me just be writing my own things, not what they've written here. Okay, so let me use white. So what the associative law states is that if you have A intersection B intersection C being equal to, let me start with the brackets being on. Okay, so the associative basically just talks about the brackets. When you change the brackets, when you change the position of the brackets, the answers that you're going to get will be the same. So you also have A intersection B intersection C. If you put the brackets this time around on, you put the brackets on B and C, the answer that you're going to get this side will still be the same answer that you get this other side. Yeah, so as long as, let me give an example in terms of numbers. So if we say 2, okay, let me write here. We say 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Put the brackets this side. So remember, according to mathematics, you always start with brackets. According to body mass, you always start with brackets. So we start with what is in the brackets. We add 2 plus 3. The answer will be what? 5. And then we add 4. This other side, we start with what is in the brackets. So we're going to have 2 plus 3 plus 4. The answer will be what? 7. The answer will be 7. So if we add this side, what are we going to get? 5 plus 4, the answer is 9. Even this other side, 2 plus 7, the answer is what? It's still 9. So if you interchange the brackets, you start with these, and then in the second question, you start with these other numbers, and you still get the same answer. It means that the operation there, the operation here, which is addition, the one that we're using, obeys what? The associative law. So if you change the brackets in sets, if you change the brackets and you still get the same answer on the left and on the right, it means that that given operation, in this case, we're dealing with intersection. Intersection obeys the associative law. So the associative law basically just talks about interchanging the brackets. That's so. When you interchange the brackets, if you get the same answer, it implies that that given operation obeys the associative law. Okay, so we proceed to the next one. I don't know if you've gotten the associative. We move on to the distributive. So the distributive law is just there to help us know how to distribute sets. If for instance, you've been given a question which is A intersection B union C, you have something like this. Then you've been told to distribute this. So this one is mostly applicable when you are simplifying sets. So to distribute this, you get A intersection, you write it there, and then you put it together with B, then you put them in brackets, then you get the symbol there which is in between. So in this case, we have union, so I'm going to put that in between. then we open the brackets, you get this same A intersection, you write it there, and then you put it together with what? With C. So it means that we have distributed the set. This is how you distribute. So let's take another example. If you have A union B intersection C, then you've been told to distribute this. So first of all, you take A union, you write it there, then you put it together with what? B in brackets. Then you get this same A union, we write it there. Oh, sorry, we get the symbol in between first. Then we write it between there. And then we open the brackets, you get this same A union, and then you put it together with that C. And this means that we have distributed the sets. Yeah, so this is basically how you do the distributive, how you deal with the distributive law of sets. Yeah, I wanted us to start intervals, but I remembered one thing. Whenever we're dealing with intervals, you need to know what real numbers are. We need to define the real numbers, and which implies that we first have to do the lecture slide. We first have to cover that slide which deals with sets of numbers. So we can't do this today because I actually even prepared a question at the end, which we were supposed to do tonight. So we can't do this tonight. If I teach this without explaining what real numbers are, to be confusing, more especially to to be confusing to some of you, you fail to understand the concept behind the intervals. Yeah, so I think for tonight, let's just end here. The next time we're going to meet, I'll first have to explain what real numbers are, then we do interval notation. All right, so good night. See you in the next session.
Good night, sir.